Hi there. We're the WVU PPI, the West Virginia Paleo Private Investigators. We're here to give you guys the down low on our latest organisms of interest. But first, we need to talk just a little bit about your training. Today, you guys are going to be working with the best of the best, the fossil detective crew. Why are you looking so surprised? You didn't read the job description? Don't get so upset. I'll give you some of the details of what we do here. We're paleontologists. We like to figure out the past in order to get to the future. We look at remnants of past life, fossils, like plant remains, animal remains, tracks, or even fossilized poop at times. It can get kind of gross. Gotta wash off after work. The cases we're working on today are a very special group of organisms, completely boneless. We're going to be working on the great, amazing, incredible horseshoe crabs. You might be thinking to yourself, what's a horseshoe crab? I gotcha. Horseshoe crabs are marine chelicerate arthropods. By the word arthropod, we mean they have a jointed leg. These are things like lobsters, spiders, and crabs. But the word horseshoe crab is a bit misleading. They're not actually crabs. If we look at horseshoe crab mouth parts, we can see they're related to things like scorpions, spiders, ticks, and mites, and even the dreaded sea scorpions. Those guys were awful. We can see that horseshoe crabs are actually pretty old. They're older than dinosaurs and life on land. We can see the horseshoe crabs, which is a part of the group known as Xiphosaura. They originated around 470 to 480 million years ago. These guys are old. These blue bloods, they've been around for some time. Yeah, these guys have really seen some stuff, and we're trying to figure out exactly what they've seen. We've got some detectives working on a case to figure out what they've been doing for the past 400 million years. You see, some evidence is showing that while we thought they were always marine, they actually have been transitioning to some freshwater environments. Kind of strange. Anyway, we got some detectives here, Lane and Hosanna, who are going to give you some more nitty-gritty details about this really peculiar and boneless case.
Alright, sleuths. As Alex said earlier, we have some important information that'll help to crack this case wide open. Mainly some background knowledge about our suspects. Earlier, our chief mentioned that horseshoe crabs have blue blood, and they weren't lying. Scientists are actually able to use an extract from the horseshoe crab's copper-based blood system in order to check medical devices for bacterial contamination, which is extremely important for us vertebrates whenever we get implants or vaccines. As well as this, horseshoe crabs have survived all 5 mass extinctions, which is extremely important for us as well, as we might be nearing another one. Another important topic is family relations, looking how one species relates to another through time. A major job of paleontologists is to look at these family relations, using what we call a phylogenetic tree. It's basically an evolutionary family tree. Starting at the base or root, we have the oldest known ancestor of horseshoe crabs, and as we continue going up the tree, we see branches moving off in different directions and splitting. Whenever there's a split in the tree, that means that multiple species have evolved from the same prior ancestor. These relations are extremely important to look at, as we can look back at ancestors and see what's changed through time to our more recent history.
Alright, so we're going to ask all of you detectives to work together in teams to investigate this mystery. And you're going to get a bag which has all of the evidence that we collected at the scene. So it's going to have a picture of the suspect, which is the horseshoe crab that we're trying to place, and it's going to have pictures of things that were found at the scene with them. And you're also going to get a poster, which has that family tree that we were talking about. So the poster is going to be used to show how the horseshoe crabs are related and where they lived. But we'll get to building that in a minute. The first step is you're going to take that evidence that you have, and you're going to look at the things that were found with the horseshoe crabs, and we'll give you a guidebook for how to interpret that, so you can figure out when and where they lived. We're going to put all the puzzle pieces together, so we're going to take our knowledge of when they lived and where they lived, and use that to place them on the family tree. We can also use how similar the horseshoe crabs look to each other, because just like with people, horseshoe crabs who are more closely related are going to be likely to look pretty similar. So we can use that as another clue when we're trying to put together this big puzzle. And when we have this put together, this family tree, this is really, really important because it shows us how the horseshoe crabs evolved over time. So when you look at your poster and when you put it all together, you're going to see that some of these horseshoe crabs lived in really different environments. So in the guidebook, you probably also noticed that some of the things that you identified were freshwater organisms. And even though horseshoe crabs only live in the ocean now, in the past, some of them lived in freshwater. So one of the things we can use this tree for, and one of the reasons it's really important, is we can use it to guess when different evolutionary changes happened. So when we look at the tree, we might see like one ancestor lived in the ocean, and then all of their descendants lived on fresh water. So we can use that to guess that the change happened in between those two, and that something happened to change the horseshoe crabs so that they could live on fresh water. So what we want you to do on your poster is mark the places where you think that that change might have happened. So we don't know exactly, because we don't have all the fossils for all the horseshoe crabs that have lived, but we can guess by looking between the different ones that we do have. We can guess where that change might have happened. And once you've done that, if you have some extra time, you can talk in your groups about why it might be beneficial for the horseshoe crabs to live in different environments. What kinds of things might they gain from living on fresh water? Or what kinds of things might happen to stop them from living on fresh water anymore?